Uh, Good afternoon, my dear children. Today we are going to learn about a new interesting topic, that is n plus n rule. N plus L rule. Here, what is meant by n and what is meant by L? Okay. N means it denotes the principal quantum number. That means it belongs to K shell, L shell, M shell, N shell, etc. Okay? That is about the principal quantum number. Tell about that orbit, that is shell. And also about the L, that is an azimuthal quantum number. Azimuthal quantum number, we are giving the value, that is subshell, it denotes the subshell. We are giving the value S subshell, the value S value is equal to 0 and P value is equal to 1 and D value is equal to 2 and F value is equal to 3. Okay? Here we are counting the shell, which is shell the electrons goes, that plus and the subshell S value we are counting, that is called the n plus L value. I am giving the rule, what is about the n plus L rule. Anyhow, it's a very interesting, you do it that one. If you are doing perfectly, then only we can be enter the next topic. Otherwise, it may be some difficult. If you have any doubt, means please call me. Okay. Next, about the energy of an orbital. Here, the hydrogen atom, it has only one electron. Okay. The energy of an electron for n orbital having one formula. Already we discussed that formula. That is equal to En is equal to minus of 12.8 divided by n square. Z square kilojoules mole inverse. That is a formula. Okay, you already learned that one. Next here, what is n depends upon the value of principal quantum number. N depends upon the value of principal quantum number. As the n value increases, the energy of the orbital also increases. This is the condition. As the n value increases, the energy of the orbital also increases. Please all of you take a note and write how the n value is increasing. Please all of you take a note. Okay. The energy of various orbitals will be in the following order. The energy of various orbitals will be the following order. While we are filling the electronic configuration, writing the electronic configuration, you know the increasing order of the energy. First I write 1s, next 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f, etc. So let's, okay, here how do I mean? What is the following order? That means all the S subshell, the maximum electron is 2. Minimum is 1. Okay. All the S subshell, the maximum electron occupation is 2 and the minimum electron occupation is 1. Okay. Like that, all the P subshell, we can be accommodate 6 electron is the maximum. 6 electron is the maximum. And start with 1, 1, 2, 3, then 4, 5, the 6 is the maximum. Because they have 3 orbitals. One is 2px, 2py and 2pz. Okay. Next about also The d subshell. D subshell, all the D subshell already we learned that one. We can be accommodate the maximum is 10. Maximum accommodation of electron is 10. And the minimum is starting with 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the maximum is 10. And that's so. If the maximum number of electrons is also 14, start with the 1. Okay, this is the condition. Okay. First of all, you should be learn about the energy of the various orbitals. That is the okay. That is 1s is less than 2s. Okay. That is 1s. 1s is less than 2s. Okay. It will be equal to 2p. It will be equal to 2p. 1s is less than 2s. It is equal to 2p. Clear? And 2p is less than 3s. Okay, less than 3s, and that is equal to 3s is equal to 3p 3. 3s is equal to 3p 3. Clear? 3p is also equal to 3d. Next, 3d is less than 4s. 3d is less than 4s. Clear? 3d is less than 4s. 3d is less than 4s. 4s. Okay. Here 4s is equal to 4p. 4p is equal to 4d. 4d is equal to 4f. Okay. 4s is equal to 4p. 4p is equal to 4d. 4d is equal to 4f. Is equal to 4p. That is equal to 4d. That is equal to 4f. And 4f is less than 5s. Okay, 4f is less than 5s. Clear? 4f is less than 5s. This 5s is equal to 5p. 5p equal to 5d. 5d is equal to 5f. 5p is equal to 4s is equal to 5p. 5p is equal to 5d. That is equal to 5f. This 5f is less than 6s. Less than 5f is less than 6s. Less than 6s. It is equal to 6p. 6p is equal to 6d. That is equal to 6f. That is less than 7s. And so on. Okay. Clear? This is about that. This is just only for the understanding. And also, here the examples about the hydrogen, the electron and hydrogen occupies oneness orbital. That is all of you know, right? Oneness orbital. This state is called ground state. Here, for example, I am writing the hydrogen. Hydrogen, the atomic number is equal to 1. Hydrogen atomic number is equal to 1. Am I right? Here, how will you write the electronic configuration? Otherwise, how will you write the energy state? What is energy state? That is called, that is 1 yes 1. Clear? First electron have to get 1s. 1 yes 1. So this state is called, which state means ground state. Ground state. Clear? When an electron gains some energy, suppose an hydrogen gains some energy, it moves to higher energy orbital. It moves higher energy orbital, that is 2s, 2p, etc. Suppose one of the hydrogen ground state is 1s, 1s1. Suppose it gains some energy. It can jump from one orbital to higher orbital. That means 2s or 2p, like that. If you are jumping, okay, it is jumping like that, it becomes an excited state. That state is called excited state. Okay, it moves up to the higher energy orbital. It moves to the higher energy orbitals. That is called excited state. That is called excited. Okay? Canada? I told you that when is a hydrogen atomic number is 1. Hydrogen atomic number is 1. Number of electrons is also 1. So, hydrogen ground state is 1s1. Okay, 1s1. Suppose when an electron gains some energy, hydrogen gains some energy, it moves higher, okay, higher energy orbital, such as what? 2s or 2p or 3s like that. That state is called what? Excited state. Excited state. Clear? Okay. Here, and the previously I told you that what is today the learning objectives, about the learning objectives, to learn about today our learning objective. What is that? That is n plus l rule. What is about the n plus l rule? Okay. First of all, how to find out the l plus l rule? That is, this rule have two conditions. What is the condition? Two conditions. This rule have two conditions. One is, first you know what is in the n and what is in the l. N means that is a principal quantum number. Previously I told you that n means principal quantum number. Principal quantum number denotes the shell of an atom. Shell means first shell, K shell, and second shell, L shell, M shell, N shell, etc. Am I right? It denotes the shell of an atom. N is equal to 1, N is equal to 2, N is equal to 3, like that. L is about the subshell. We are studying about the subshell. Okay, subshell. That is about the shell. L, okay. Here, what is about the n plus l rule? N plus l rule. Okay, this rule should be like, learn that. What is that only? It states that the lower energy, otherwise, the lower value, the value of n plus l, lower the value of n plus l for an orbital, the lower is its energy. This is the first condition. Clear? What's about that? It states that the lower the value of n plus l, the lower the value of n plus l for an orbital, the lower in its energy. The lower the value of n plus l for an orbital, the lower is its energy. That's the first condition. About the second condition, if two orbitals have same value, if the same value of n plus l, okay, same orbital, for example, for 5s and 5p, like that, same orbital, okay, the same two orbitals have same value, not same orbital, two orbitals have the same value, that is n plus n. The orbital, this is a condition, the orbital with low value, the orbital with the low of n will be considered. N will have the lower energy. Here, only that if you are learning the n plus l rule, you must learn about the 2 points. First point is, the lower the value of n plus l for an orbital, the lower is its energy. It's the first condition. The second condition, if two orbitals have the same value of n plus L, the orbital with low value of n will have the lower energy. How can we find out which one have the low value, which one have the lower value? How can we find out? First, please all of you open the note all of you. We can be write which one have the low value and which one have the high value. Like that we can be write. Okay. Please all of you take the note. First we should write n plus value of different orbitals. N plus, okay, n plus L values of different orbital. N plus L values of different orbitals. First, which are the orbital is there? 1s, 2s, 2p, 3s, like that. 1s, 2s, 2p, 3s, 3p, 3d, 4s, like that. You should be right. Okay. Can I write? No. Say orbitals. First, we make the table a column. Which one is the first one? 1s. First, we write orbital. This is n. N means principal quantum number. L means azimuthal quantum number. We are adding n plus L. N plus L. Clear? That first one you should write 1s. Okay. 1s. Next one 2s. Next one 2p. Next one 3s. After the 3s, 3p, 3d, 4s, 4p, 4d, after 4d, 4f, okay, etc., etc. After the 4th, will you write 5s? Okay, 5s. Next 5p, 5d, 5f, 6x, 6p, 6t, 6x, 7s. Okay, like that. So I'll write here. Okay. 4f, 5s, 5p, 5p, next 5d, next 5f, next 6x, 6p, 6t, 6f, 7s. Okay. Okay. First you will start with the 1s. Okay, 1s only 1, 2s 2, 2s and 2p. Next 3s having 3, 3s, 3p, 3d. Next one 4, remaining all 4. Okay, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f. So it's like that. Okay, clear. And right. Okay. Here First one, how will you write the oneness? Here, the principal quantum number, oneness, that means, how will you write? That is, n is equal to 1. What is about the L? Here, L means we are writing for S subshell. S subshell, the value is always 0. P subshell, the value is 1. D subshell, the value is 2. And F subshell, the value is 3. Okay? Okay, clear? Clear? What is about the S is always 0. Say all of you. S is always 0. What about P? The value is 1. What's about the D? The value is 2. And what's about the F? The value is 3. Here, oneness. Oneness means it denotes the K shell. Am I right? It denotes which shell? K shell. We are saying oneness. That means 1 yes 1. It denotes which shell? K shell. Am I right? K shell. Okay? Oneness is always oneness 1 and oneness 2 are which shell? K shell. So n is equal to 1. Here L is equal to. Here 1 yes means that is yes subshell. Am I right? So the value is 0. For yes, the value is 0. Here, L means azimuthal quantum number. It denotes the subshell. It denotes the subshell. Subshell. First one is yes. Yes, the value is all the yes. The value is 0. Whether it may be 1 s or 2 s or 3 s or 4 s or 5 s or 6 s or 7 s. All the yes value is 0. What about the P value? All the P value. Okay, P value. That means 2p, 3p, 4p, 5p, 6p. That's all what? The value is 1. And also all the D value, 3d, 4d, 5d, 6d, etc. The value is 2. And also F value, all the F value, F, 4f, clear, 4f and 5f, 6f, the value is 3. Have it out. This is the basic principle, okay? So all the S value, whatever may be all the S value, the principal, the azimuthal quantum number L value, all the S value, the azimuthal quantum number L value is 0. Okay? All the P, all, which may be, okay, all the P, the azimuthal L value becomes 1. For all the D subshell, the azimuthal L value becomes 2. For all the F, okay, the azimuthal L value becomes 3. This is the condition. Okay? Here, when we are adding, 1 plus 0 is equal to what is the answer? 1. 1 is the answer. Next about, it denotes K shell. Am I right? I told you that is, okay, n is equal to 1. First orbit. Am I right? First orbit we can be accommodated 2 electrons. Second orbit, how much electrons? I told you that 8 electrons. Okay, 8 electrons means it denotes the K shell. Am I right? Which is shell? K shell. Okay, so 2s become K shell. We are saying n is equal to 2. Okay, n is equal to 2. And S subshell, I told you that all the S subshell, what's the value? For azimuthal quantum number? 0. So what's the n plus L value? 2. Clear? Have it out? Have it out? All the S subshell, the L value becomes 0. All the S subshell, the L value becomes 0. That is azimuthal quantum number value 0. All the P subshell, the azimuthal L value becomes 1. And D subshell, the azimuthal L value becomes 2. and f sub shell, the azimuthal L value becomes 3. Clear? Okay. Then L should be right which orbit or which shell the electron is occupying. Okay. 2s means n is equal to 2. N is equal to 2 denotes that it becomes K shell. Okay. Sorry, second shell. Okay, second shell. L shell. Okay. That's about the P subshell. What is about the P subshell? It occupies L shell. That is n is equal to L shell. Oh, L shell means number is 2. What is about the value of P? I told you that the value of P becomes what? This is 1. So 2 plus 1 is equal to 3. Clear? 2 plus 1 is equal to 3. Can you say about the next one? 3s. What is about the 3s? It is occupied where n is equal to 1 or n is equal to 2 or n is equal to 3. N is equal to 3. N is equal to 3. This is n is equal to 1. Okay? This is n is equal to 2. This is n is equal to 3. This is n is equal to 4. N is equal to 5. N is equal to 6. N is equal to 7. These are all what? Principal quantum number. Okay. This one line n is equal to 1. This one line n is equal to 2. This one line n is equal to 3. This one line n is equal to 4. This one line n is equal to 5. This one line n is equal to 6. This one line n is equal to 7. Clear? Clear? Have it down? No. Okay. Next about, can you say about the 3s? 3s is where it is occupied. N is equal to 1 or 2 or 3? 3. Am I right? 3. Next, what is about the S value? I told you, S value is what? 0. 0. Then 3 plus 0 is equal to 3. Next, P subshell. N is equal to what? N is equal to 3. Next, L value. For P subshell, L value what? L is equal to 1. So 3 plus 1 how much? 4. Okay? Have it now. Can you say about the D? 3D is occupied where n is equal to 3. Okay, n is equal to 3. And L value. What is about the DL value? D value is 2. So 3 plus 2 is equal to 5. Okay? Next about 4s. 4s occupied where n is equal to 1 or 2 or 3 or 4. N is equal to 4. So it should be right 4. And all S value. What's the answer? S value 0. Okay, S value, all the S value becomes 0. Then what's the answer? 4 plus 0 is equal to 4. Then 4P. What is n is equal to? N is equal to 4. About the P value 1. 4 plus 1 is equal to 5. Clear? Then what is about the n plus L value? About the 4D lie on where n is equal to 4. N is equal to 4. Then 4D, the value goes to 2. 4 plus 2 is equal to 6. Alright? Then 4F, n is equal to 4. And F value, F means 3. 7. Clear? Next, 5s, n is equal to where? 5s, n is equal to 5. S value 0. S value 0. So what's the answer? 5 is the answer. Next about 5P. N is equal to 5P. N is equal to 5. Next, P goes to 1. 5 plus 1 is 6. Clear? Next about 5D. N is equal to 5D. N is equal to 5. Then D value 2. 5 plus 2 is equal to 7. Okay. Then 5f goes to where? 5f. N is equal to 5. F means 3. That is 8. Okay. Can you find the sixth one? 6s. 6s is lie on where? N is equal to 6. S means 0. 6 plus 0 is equal to 6. Then 6p. N is equal to 6. P means N is equal to 1. So 7. 6d. N is equal to 6. D means value is 2. So 8. 6f. N is equal to 6. And F means 3. 9. Okay. 6f. Okay. And what about the 7? 7s. 7s. N is equal to 7. And S means 1. So it is said. So S is 0. Okay. 0. S means 0 and 7. Okay. These are the values. Next, how to write the increasing order of energy as per this rule? As per this rule, n plus n value. Okay. As per this rule, n plus n value. How will you write the increasing order? How will you write the increasing order? Okay. Start with the increasing order. First, 1s, 1 card, 2s, okay, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s. This is the order. Clear? Okay, can you write? First 1s, next 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s. Okay, don't change orbital. As per the line, you should be right, the increasing order. Okay, based on the n plus L rule, based on n plus L rule. Okay, based on n plus L rule. Here, increasing order of the orbital, increasing, start with 1s. Okay, first is occupied 1s, so you should be right what? 1s, 1s. Next one is, second one is 2s, 2s. Third one is 2p. Next one is 3s. Next one is 3p. After that 4s. Then 4s. Next over 3d. Am I right? As per the line, it should be right. 3d. 3d means next one 4p. Next one 5s. Next 4d. 4 will be after 5p. 5p next 6s. After that 4f. Next 5d. Next 6p. Next 7s. Can you write this increasing order? As per this line, you should be right. Okay, as per this, don't back up this one. As per this line, okay, 1s, 2s. Let's start with this side, okay, not this side, start with this side. Start with here, 1s and ends the arrow. Start with here and ends with this arrow. That is 1s. Next start here, 2s. Next start with here, 2p, 3s. Next 3p, 4s. 3d, 4p, 5s. 4d, 5p, 6s. 4f, 5d, 6p, 7s. This is the increasing order. Yeah, this is what? The increasing order. Then how can we check? How can we check whether it's correct or wrong? Okay. How can we check whether it is a correct or wrong? Then please solve it. Already I told you about that n plus l value. N plus l value. What is n plus l value stated? I told you that the lower the value of n plus l for an orbital, the lower is its energy. First condition. Say all of you. What's the first one? The lower the value of n plus l for an orbital, lower is its energy. This is the condition. Here, n plus value is how much for 1s orbital? N plus l value is how much? 1. So, what is that one? The lower the value of n plus l of an orbital, lower its energy. Second condition, for 1s orbital, it's a lower energy, 1s orbital, so the n plus l value is how much? 1. Next, about the 2s orbital. 2s orbital. What's the n plus l value? 2. Okay. Then, here having 2 items, am I right? 3, because 2p also having 3 and 3 is also having 3. Which one is have the higher energy? Which one have the lower energy? As per this line. As per this line. Here, which have the priority? Here 2p also having 3 and 3 is also having 3. Am I right? 2p also having n plus l value 3 and 3 is also having n plus l value 3. Which one have the lower energy and which one have the higher energy? Please take the state that rule. N plus l value rule. That's the first one is the lower the value of n plus l for an orbital, lower is its energy. Second one, if two orbitals have the same value, okay, if two orbital have the same value, two orbital means 2p and 3s, 2p and 3s, okay, 2p and 3s having the same value. Which value is there? Same value is 3, okay. The orbital will low value of n will have the lower energy. Out of this 3, which one have the n value? That's principal quantum number value is low. Okay. N plus l value 2p and 3 is have the same. Same is 3. Okay, 3. That's okay. But which out of these two orbital, which have the least value for n? N value, which have the least value for n? That is 2p. So 2p have the low value. What do you understand? Please tell me. What do you understand about this area? First one, as per the n plus n value, which have the higher energy. Okay. Second step is, what is about that? What is about the second step? When we are two orbital, we are taking the 2 orbital or 3 orbital or 4 orbital, have the same value. For example, 3 or 4 or 5 like that. 2 orbital have the same value for n plus 1. Here, you should be find out the orbital with the low energy of L. Okay, orbital which have the low value for n. N means principal quantum number. N value is low. They have the low energy. Okay. So here, we are searching here means here 2p have the low value. That is n is equal to 2 and 3s having n is equal to 3. So 2p is the lowest energy. As we are comparing 3s. 3s have right. Okay. Next about we are looking at one. 3p have 4 and also 4s have also 4. Am I right? Which have the 4 having here? N plus n value? 3p and also 4s, which have the low value. When we are comparing, the n is equal to 3 for 3p and n is equal to 4 for 4s. So, which have the low energy? 3p have the low energy. So, 3p have the low energy and 4s have the high energy. Am I right? Next about the 5. We are comparing the 5. That is 5 is 3d also having 5 and also 4p also having 5 and 5s also having 5. Can you say which have the low energy? 3d have the low energy because n is equal to 3. Okay. Next one. 4p have the low energy, that is equal to n is equal to 4. Okay. We are writing like that only. Okay. That means 3d. After that 4p. Okay. After that 4d. Like that. We write. Sorry. After that 5s. Okay. Next about 5 value. We can find out the 5 value. Which are the having the 5 value? 5 means 3d. 4p that is over. Next about 6. 6 means which are the having 6? 4d. 4d have the 6 value. Then 5p have the 6 value. And also here also value. 6s have the value. The same value. 6. Okay. This 3 having. Out of this 3, which have the low value. Okay. As per the principal quantum number, n is equal to 4 for 4d. So it have the low value. It have the low value. Next one. 6 on 5p. n is equal to 5. Okay. Next 6 is we write as per this order. Okay. Next about the 7. 7 also having 7 1 2 3 4. 7 how is having? 4 having. Which are 7 having? 4f also having 7. Next 5d also having 7. Next 6p also having 7 and 7 is also having 7. Okay. So as per the principal quantum number, 4f have the low value. Okay. 4f have the low value. Next about 5d. Next about 6p. Next about 7s. As per this order, you should be right. And also today assignment, you should be right in the same question. Assignment is I think that the page number 51. 51. That is what is about that? N plus L rule. N plus L rule. That is you should be learn. Okay, learn and write the n plus L value for different orbital. N plus L value for different orbitals. Okay, these are the two assignments. As I think that the page number 51. That second paragraph you start with. I think that seventh line. About the n plus L rule, it states that the lower the value of n plus L for an orbital, the lower is its energy. If two orbitals have the same value of n plus L, the orbital with the low value of n will have the low energy. Okay, low energy. That much is enough for the n plus L rule. Next, that you do the Laplace column. Then next side, based on the n plus L rule, the increasing order of energy of an orbital is follows that order. So you should be right. Okay. Okay. Thank you all of you. Thank you. Have a nice day.